Physics chapter 19, question number 14 and 15. Question number 14. The vibration of a component in a machine is represented by the equation x equals 3.0 into 10 to the power minus 4 sine within brackets 240 pi t, where the displacement x is in meters. Determine the amplitude, frequency and period. So now we have to understand that there are two equations that we have of this sort. One has a sine value, the other has a cosine value. So the two equations are these. So these are the two equations. X equals xo sine omega t, the other one x equals xo cos omega t. So what they have used in this particular situation is this equation. So we have to make use of that equation. X equals xo sine omega t. What is x? X is the displacement. Then xo is the amplitude. Then sine omega is the frequency. Right? So these details you have to know. X equals xo sine omega t. So let's make use of those and try to figure out what they have given. Right. So now let's write that equation and see whether we can substitute those values. Sine omega t. Right. So now in sine omega t is from here. This is sine omega t. Right. So that means this part 3 into 10 to the power minus 4 is equal to what? Is equal to xo. That is the amplitude. So they are asking for part A, they are asking for amplitude. So amplitude is going to be 3 into 10 to the power minus 4. Because that is the equation that they have used and those are the details they have filled in. So our answer for the first part is amplitude is 3 into 10 to the power minus 4 meters. And if you want, you can convert that into millimeters. It is going to be 0.3 millimeters. Then they are asking for frequency. What is the equation? The equation is x equals xo sine omega t. Omega is the frequency. So that means here what is that represented by? Omega is represented by 240 pi, because omega t is what we have. So that means 240 pi is equal to omega. Right? So that's what they are asking. Now a single vibration or a single oscillation can be equal to 2 pi. Right? Single vibration is 2 pi. One whole vibration is 2 pi. We have discussed that earlier. So then we divide 240 pi is the frequency. Right? That is omega. So to find the frequency, you divide it by 2 pi, then you will get the value 120 Hertz. I hope you understood. Then they are asking for period. Right. So the part C, they are asking for the period. So now using the angular frequency omega, we have found the frequency. Frequency is 120. Then we know the equation that connects period and frequency. Period, that is T is equal to 1 upon F. T equals 1 upon 120. Then T is going to be, you use your calculator, 8.3 into 10 to the power minus 3 seconds. I hope you got the answers. If you have any doubts, please raise them. Then question number 15. A trolley at rest tethered between two springs. So there is a, let's see what let's draw a kind of a sketch and see. If you find it difficult to do these kind of questions, always draw a sketch, that will help you out. A trolley is at rest tethered between two springs. Now it is pulled 0.15 meters to one side. So it was originally like this. Originally this trolley was tethered between two springs. So these are the two springs. These two parts are the springs. Then they are tethered between it. Now it is at rest. So it is pulled to one side 0.15 meters. It is pulled. And when time t equals 0, it is released. So now you know that this is at its maximum displacement when t equals 0. So when it is at maximum displacement, you know which equation to use. X equals xo cos. Yeah, cos. That is the equation you need to use. So I hope you can remember. We have two equations. X equals xo cos omega t is what we need to use when the displacement is highest at t equals 0. So we use that equation here. So now while reading this halfway through, we know which equation to use. So so that it oscillates back and forth with SHM, the period of its motion is 2 seconds. So they have given the maximum displacement, right? So they have given the maximum displacement 0.15. And they have given so the maximum displacement is obviously the amplitude. They have given amplitude to be 0.15, and then they have given t, or the capital T, the period has been given. Write an equation for its displacement x at any time t, assume that the motion is not damped by frictional forces. So we have to disregard that. So what is the main equation that we have? Our main equation is x equals xo cos omega t. Now let's substitute the values that we know. X is the displacement. Xo we know. What is xo? 0.15. Right? Then cos omega t. Is our answer. I hope you understood this. Then sketch a displacement time graph to show two cycles of the motion giving values where appropriate. Right? Oh wait, but before this we can actually we can simplify this a little further, because we have another detail that they have given. That is, they have given a way for us to simplify omega. Right? Omega is angular frequency. So then omega can be simplified because omega is equal to 2 pi. Right? But because there are two, frequency is 2, the period of motion is 2 seconds. Right? Period of its motion is 2 seconds. Then you can, the frequency is going to be half. So then you can find the relationship between these two, and you can take omega to be instead of omega you can use pi. X equals 0.15 cos pi t, cos pi t. I hope you understood the relationship. If you did not, please raise questions. I will explain it further. Right. Then they are asking, sketch a displacement time graph to show 2 cycles of the motion giving values where appropriate. Right. This is once again, it's quite easy. So you have a displacement time graph. Because it is simple harmonic motion, it is happening to both sides. So let's take right hand side to be positive and the other side to be negative, right? So this is plus 0.15. You have to write it on the other side because I don't have space. I write it on the, you have to write it on the left hand side. I'm writing it on the right hand side because I don't have space. Like I have drawn this, written this 0, that is where you have to write. So this point is negative 0.15, right? Then period is 2, right? So let's say this is 4. I will make some adjustments because it is not balanced. So this is 2 and this is 4 seconds, right? So that means period is 2 seconds, means one single wave happens in 2 seconds. That is how it goes, right? So this is how it happens. So this is the graph that you need to draw. At the examination, you will be getting about 5-6 marks for this type of a graph. I hope it made sense. If you have any difficulties, please ask me.